I am Dr. V. Priya, Assistant Professor of Chemistry, Vellalar College for Women. Now, molecular orbital theory. Molecular orbital theory was first proposed by Hunt and Millikan, and it is defined as the valence shell atomic orbitals mixed up to form a new set of orbitals known as molecular orbitals. It contains bonding molecular orbitals and antibonding molecular orbitals, and it describes about the energy level diagram for each molecule, and the electrons should be filled in molecular orbital by following Afuba principle, Pauling's exclusion principle, and Hund's rule, and it describes about the bond order and the magnetism of molecule. Now, linear combination of atomic orbitals, LCAO. It is the method of obtaining a wave function for the molecular orbital from the wave function of atomic orbital. Wave function of atomic orbitals overlap to give wave function of molecular orbitals. It gives psi A, psi B equal to psi, and psi A, psi minus psi B is equal to psi star AB. Bonding molecular orbitals. Bonding molecular orbitals are formed by the combination of electron waves of the same sign. It is addition overlap of atomic orbitals. Psi equal to psi A plus psi B. It possesses lower energy than the atomic orbitals from which it is formed, and the electron density between the nuclei is high. Attraction between the nuclei is high, so bond is formed between the molecule, and bonding molecular orbitals stabilizes the molecule. Antibonding molecular orbitals. Antibonding molecular orbitals are formed by the combination of electron waves of the opposite sign. It is the subtraction overlap of atomic orbitals, and it is indicated by star. Psi star is equal to psi A minus psi B. It possesses higher energy than the atomic orbitals from which it is formed. It has lower electron density between the nuclei. Repulsion between the nuclei is high, so bond is not formed, and it destabilizes the molecule. This is the energy level diagram in which two atomic orbitals on the right and left, and molecular orbital is in the center, and two atomic orbitals combine to form two molecular orbitals, one as bonding molecular orbital indicated by symbol sigma, and another as antibonding molecular orbital indicated by sigma star. And the electron should be filled in the molecular orbital using Afuba principle, Pauling exclusion principle, and Hund's rule. Afuba principle is the increasing order of energy. Electron should be filled in the increasing order of energy. First, the lowest energy molecular orbital should be filled, and then only going to the next higher energy molecular orbital. And then Pauling exclusion principle. According to Pauling exclusion principle, maximum of 2 electrons should be present in one molecular orbital. And Hund's rule means 2 electrons should be in opposite spin. And bond order can be calculated using the formula number of electrons in bonding molecules minus number of electrons in antibonding molecules divided by 2. And then magnetism, whether it is diamagnetic or paramagnetic, it can be predicted using the diagram. If all the electrons are paired or even number of electrons are present, then it is diamagnetic. If all the electrons are not paired or odd number of electrons are present, then it is called as paramagnetic. Now, applying molecular orbital theory, we are going to see nitrogen molecule. For nitrogen molecule, atomic number of nitrogen is 7, and its electronic configuration is 1s2, 2s2, 2p3. Bond order, we are going to draw the energy level diagram. Energy level diagram for valence shell only we have to draw the energy level diagram. Here 2s2, 2p3 is the valence shell. So 2s2, it is having 2 electrons in both the atomic orbitals, and 2p3, so p orbital having 3 molecular orbitals and 3 electrons are filled in 2p orbitals in both the nitrogen atom. Nitrogen atom combined to form nitrogen molecule, and in 2s orbital we are having totally 4 electrons. It forms sigma 2s and sigma star 2s molecular orbitals. 4 electrons should be filled using Hund's rule, Afuba principle, and Pauling exclusion principle. So first lower energy sigma 2s is filled with 2 electrons, and then remaining 2 electrons are filled in the sigma star 2s orbital. And coming to 2p orbital, we are having totally 6 electrons in 2p atomic orbitals. So those 6 electrons should be filled in first pi 2px and pi 2py molecular orbital are present, and sigma 2p 2px molecular orbital is present. Then sigma pi star 2p pi star 2px and pi star 2py molecular orbital there. Then sigma star 2pz molecular orbital is there, filling the 6 electrons in first pi 2px and pi 2py. It contains 4 electrons, and then going to sigma 2pz we are having 2 electrons. So now we are going to write the bond order. For writing bond order, number of electrons in bonding molecular orbital is in sigma 2s 2 electrons, pi 2px and pi 2py 4 electrons, sigma 2pz 2 electrons, totally 8 electrons. 8 minus in sigma star 2s 2 electrons. So 8 minus 2 by 2, which is equal to 3. So there are 3 bond present between 2 nitrogen atom, 1 sigma bond and 2 pi bonds. And coming to the magnetism, all the electrons in the molecular orbitals are paired, so it is diamagnetic. And bond energy for nitrogen molecule is 942 kilojoule per mole. Thank you.